Hello everyone, this is Aditya, and from today we're going to start a series on number theory, and we will do it in lecture form. And of course, I will try to keep it short, not that long lectures, so that you can also study it efficiently, right? And yeah, it will include, like, I suppose that it will take around 15-20 lectures for this topic, because of course it's a very big and a very vast branch of mathematics, which requires lots of problem solving and analytical power, right? So that is why it will take some time to discuss it. So that is why I'm not making one shot for it. We will discuss it properly, right? So today we are going to discuss about divisibility of integers, right? So let's start the lecture, but before that, please do like, share, subscribe my channel, and please support this video. Now let's start. So what do we mean by number theory? Well, number theory is basically the study of integers, right? That is all about number theory, right? This is the basic definition. How we factorize them, how we check for divisibility, what are the operations on integers, and all sort of those things, right? Just if you use some of your analytical parts, you'll be able to do number theory in no time, right? If you know the basic concepts of integers, you can easily do number theory. You can easily understand number theory, right? And of course, it has many concepts. So of course, we will be dealing it slowly, not we will go in a rush, right? So let's start. So today's topic is divisibility of integers, right? Okay. So let me define you a term. Let me write it like this: Roman one, right? Okay. Now, if I say x divides y, then what does it mean? Well, let me write its notation. It is given like this: x divides y. So it means that x divides y. Okay. So it means that y is divisible by x, which means that y is equal to ax, right? Ax, where a belongs to integer, right? Of course, x and y are integers, right? That's obvious, right? We write it I or z, right? Okay. And if I say x not divides y, that is x, we just put a cross sign over here. Y, it implies y is not equal to ax, right? So if we take an example, suppose 2 divides 4, of course we know it, right? Which means that 4 is equal to a times 2, that is 2a, right? So of course here we get a is equal to 2, right? So it is an integer, right? Correct. But 3 does not divide 4, right? Which implies that 4 is not equal to a times 3, or 4 is not equal to 3a, right? And of course, if you try to solve for a, you will get a is equal to 4 by 3, which is not an integer, right? So it means that 4 is not divisible by 3, and it means that 4 is divisible by 2, right? So we say it like 2 divides 4, but 3 does not divides 4, right? Okay. So this is the basic which you should know. Now let's understand divisibility of integers, right? Now what are the conditions to be divisible by certain numbers? I mean by 2, by 3, by 4, by 5. We won't discuss for 6, 7. We will discuss for 8 then. 8, 9, 10, 11 we can discuss, right? So we will discuss for these numbers, right? And of course there are other numbers too which we can discuss, but we are not going to discuss right now. We will discuss it later, right? So for 2, suppose the number is, let's assume we are dealing with a number n, right? And of course n belongs to integer, right? N should be even, right? Okay, correct. For 3, sum of digits of number must be divisible by what? Divisible by 3, right? Okay. So suppose if I say 136, so what is the sum of digits in this case? 1 plus 3 plus 6, which is equal to 10. Now 10 is not divisible by 3, hence it is not divisible by 3, right? Right. Now what is the condition to be divisible by 4? Last 2 digit must be divisible by 4, right? we can take its example. Suppose 28 is divisible, right? So in this case, suppose you have 128. So we can see that 128 in 128, 20 is divisible, 28 is divisible by 4, right? And this whole number is divisible by 4, right? Correct. And for being divisible by 5, last digit or units digit must be 0 or 5, right? And if you have to check for divisibility for 6, of course 6 can be written as 2 into 3, right? So it should be divisible by 3 and it should be divisible by 3 also, right? To satisfy the divisibility by 6, right? So that is why I am not discussing that, right? And for 7, it is actually a bit long procedure, so that is why I am not discussing it right now, because there are other methods also to find divisibility by 7, right? Which we will discuss, not right now. Okay, okay, for divisible by 8, last 3 digits must be divisible by what? By 8. For example, 1 6 4 8. 6 4 8 is divisible by 8, of course, right? So this whole number is divisible by 6 by 8, I mean, right? And to be divisible by 9, sum of digits must be divisible by what? Divisible by 9, right? For example, 3 3 3 4 5 6 9 9 and over here 9, right? Okay, and yeah, we can take an example as 336, or you can take 39, because 36 was divisible by 9 also, so you would get confused. So of course, if a number is divisible by 9, it is obvious that it will be divisible by 3, since 9 is equal to 3 square, right? Okay. Now for 11, sum of, I mean, difference of sum of even and odd position terms should be divisible by 11. What do I mean is that, suppose you have 1 2 1 5 5. Suppose this is the number, okay? So we will name it like first position, second position, third position, fourth position, and fifth position, right? Correct? Okay. So sum of even positions 2 and 4, right? So 2 plus 5, which is equal to 7. What is second term? It is 2, and what is fourth term? It is 5, right? And this is for odd, I mean even terms, and for odd terms it is 1 1 and 5, correct? So that is 1 3 5. What is the number at 1? It is 1. What is number at 3? It is 1. And what is number at 5? It is 5. So 1 plus 1 plus 5 is equal to 7. This is odd. Hence their difference 7 minus 7 is equal to 0, and 0 is divisible by any number, right? Which implies that this number 12155 is divisible by 11, correct? So this was some of the basic divisibility of integers which you should know, and there are some other numbers also which we should discuss, but I am not discussing it right now, because you will ultimately get confused, because it is the first lecture, right? So let's erase this and let's see some of the properties. Okay, so let's do a question also. Find n such that, it means such that, okay, such that the sum of digits of 10 to the power n minus 1 is 6057, right? So how can we solve this problem, right? So let's analyze this. I said you analytical power is really important in this branch of mathematics, correct? So let's substitute n is equal to 1. Of course n is an integer, right? A positive integer, of course. So if n is equal to 1, so we get 10 to the power 1 minus 1 is equal to, I mean 10 to the power 1 minus 1 is equal to 9. Okay, n is equal to, we get 10 square minus 1, which is equal to 9. So when you substitute n as 3, you get 10 cube minus 1, which is equal to 999, correct? And so on and so forth. So if you analyze it, you will understand that if you put n is equal to some k, then 10 to the power k minus 1 will be equal to 9, so on till 9. And how many times they will come? K times. Understood why? When you put n is equal to 1, you got 9. When you substitute n is equal to 2, you got 9. For 3, you got 9, right? And so on and so forth, right? Okay, but what will you do of it? We can do lots of things from this. We know that we have to find such n, right? Okay. So it means that 10 to the power n minus 1, that is the sum of digits of the quantity 10 to the power n minus 1 is equal to 9 plus 9 plus till 9. And how many times 9 are there? There are n times, right? N times, right? So it is equal to 9n, right? So the sum of digits is equal to 9n, correct? Okay. So we can say that 9n is equal to 6057, right? Hence we get n is equal to 6057 divided by 9, we get 32013. So we get 309. So we get over here 673. So we get 673 as the answer. So it means that 10 raised by 673 minus 1, when you take the sum of digits of this number, you will get this number, right? And it's so amazing that this problem seemed to be so hard, but it became so easy on just analysis, right? That is what you have to do in whole number theory, right? That is what is number theory, right? Okay, so let's erase this and let's discuss some of the properties, or let me see if there is another question, right? So we have a question. Number 64 has the property, that it's divisible by its units digit, that is by 4 in this case. How many such numbers are possible from 20 to, or let's take from 10 to 50? Let's solve it, right? Now it's amazing problem, you can try it also, right? So let's see it. Okay, so number 64 has the property that it is divisible by 4, right? So how many such numbers are possible, right? So in this you have to make some cases, right? What will be the units digit, right? It can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? Of course, divisible by 0 don't exist, since the division by 0 is not allowed. So we remove 0. Now let's consider for 1. Of course, 1 divides all numbers, right? Hence 11, 21 and 31 and 41, they are divisible by 1, correct? Okay, now let's consider 2, right? So 22, correct? 32, correct? 42, of course 12 is also there. 12, 32, 22, sorry, 32 and 42, they are divisible by what? Divisible by 2, correct? Correct or not? Correct. Okay, now let's check for, so we checked for 1, we checked for 2, let's check for 3. So for 3, the first number is 13. So of course 13 is not divisible by 3, so it will not be included. 23, no, it will also be not included since it is not divisible by 3. Now let's assume 33, yeah, it is divisible, right? So 33, 43, no, it is not divisible. So it is divisibility or divisible by 3, correct? We check for 3 also. Now let's check for this 4, right? So we will get 14, 24 and we get 34, 44. So of course 14 is not divisible and 34 is not divisible. So we have 24 and 44, right, which are divisible by 4, correct? Okay, we can remove this also. And for 5 we will have 15, 25, 35 and 45. So they are divisible by 5, correct? Okay, so we can remove it also. Now divisible by 6. Is 16 divisible by 6? No. 26? No. 36. 36, it is divisible by 6, right? You have to just apply some of the analytical skills and you will see that yeah, it is easy. Now for 7, 17, it is not divisible. 27, no. 37, no. 47, no. Hence there is no number which is divisible by 7, right? We can remove it. Okay. Now for 8, we have 18, no. 28, no. 38, no. 48. So 48 is divisible by 8, correct? Okay. Now let's check for 9. 19, no. 29, no. 39, no. 49, no. Hence, no number is divisible by 9 also. So, how many numbers we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So, we got 17 such numbers, right? And that is the answer, right? Did you understood what I did? So, I basically checked what can be the number in the units place. Of course, 0 cannot be there. So, we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So basically we can have 11, 21, 31, 41 for divisibility by 1 because we want this number to divide this number, right? Because we want the units digit to divide that complete number, right? That is why we are doing this, right? Simple. Okay. Yeah. So now let's move to the next topic. So let's discuss properties of division. Properties of division, right? Okay. Or divisibility, we can say divisibility, right? So the first one, if A is dividing B and B divides C, it implies that A divides C. Okay, so I wrote this property, but how can you say that is it true? Well, if you want to prove, it is very simple, right? How you can prove? I said that this implies that B is equal to some constant times that number, right? And C is equal to some constant times that number, right? Some value, this is an integer value, K1 and this, right? So how can we prove it? Well, we know the value of B, it is equal to this. So C is equal to K2. Substitute the value of B, K1 times A. Now K1 times K2, it is again integer. Integer multiplied by integer is equal to integer, right? Hence, this is implying that C, that is A divides C, correct? Correct or not? Correct? Okay. So now let's see the next property. If A divides B and A divides C, then it implies that A divides K1B plus minus K2C, right? Okay, let me tell. And of course, A, B, C, K1, K2, all are integers, right? Okay, but how we went from this to this? You must be thinking. Let me tell you. Suppose we can write B as some value like alpha 1 into A, right? Let's assume alpha 1 into A and C as alpha 2 into what? Into A, right? We can say it like this, correct? Okay. So let's multiply both sides by K1. So K1B is equal to K1 alpha 1 into A, and let's multiply over here K2, which is equal to what? Which is equal to K2, sorry, K2C, K2 alpha 2 A, right? Correct? Okay. Hence, we can say from this that A divides K1B and A divides K2C, correct? Since K2 is an integer and alpha 2 is also integer, right? K and alpha both are integers, right? And again, what you can do is that you can just add these two quantities. When you add them, what you get? You get K1B plus K2C is equal to what? K1 alpha 1 plus K2 alpha 2 multiplied by A, correct? If you want, you can take plus minus sign also, right? Understood, right? Now notice that this is again an integer. Integer K alpha is always integer, right? Since K is integer, alpha is integer. So integer plus minus integer is always an integer, right? Which implies that A divides K1B plus minus K2C also, right? So of course you could have used some other method also to prove it, but it is my way of teaching that I try to break the expressions in algebraic form to explain you, because you are well familiar with algebraic expressions, so that you can easily understand what is going in these terms, right? That is how you can check it, right? Simple. Okay, suppose a divides b and a divides b minus c, then it implies a divides c also. Okay, but how can we prove it? Let's see. So b is equal to k1a and b minus c is equal to k2a. Correct? Correct. Now just subtract them, right? So we get b minus c is equal to k1 a minus k2 a. So we get c is equal to k1 minus k2 a, which implies that a divides c, right? Hence proof. In fact, instead of negative sign, instead of reference, if you had plus minus, then also it was true, right? It is valid for plus also, right? Because when you subtract, you will get you will always get that b has cancelled, right? And some or the other way, you'll get a divides c, right? For plus one, you can check yourself, right? It will be simple, right? You can do it. If a divides b and b divides a, then it implies that a is equal to plus minus b. How can we prove it? Well, b is equal to k1a and a is equal to k2b, right? Correct? Correct or not? Correct? Right? It implies this only, right? So we can substitute over here. Suppose we substitute the value of b over here. So a is equal to k2, k1, a, right? Correct? So a and a gets cancelled. So we get k2 times k1 is equal to 1, right? And we know that k1 and k2 both are integers also, right? Hence it implies that k1 is equal to k2, right? Is equal to 1 is equal to plus minus 1. Why? Because 1 times 1 is also equal to 1 and negative 1 times negative 1 is also equal to 1, right? So k1 and k2 both are integers. That's why, right? Okay. Hence we get b is equal to a or b is equal to negative a, right? Or just this, right? Understood? So from this we get this thing, okay? Now suppose a divides b, yeah, a divides b, that's it. Then what does it imply? Let's see it. So it implies that b is equal to 0, either b is equal to 0, or since 0 is the multiple of every number, right? Correct or not, right? 0 into anything is always 0. Hence 0 is the multiple of each and every number possible, right? So either b has to be 0 or mod a must be less than equal to mod b. Correct or not? Correct. Since we are saying that b is equal to a, we are saying that suppose b is equal to k times a, right? Where k belongs to integers, right? So of course either k can be 1 or it can be greater than 1, right? So that is why, and of course we can go in positive negative sign both, right? So that is why we put a mod sign over here, so that mod k always becomes positive, right? So what is the value of mod k? It can be 1, 2, 3 and so on, right? And what's the value of k? It can from negative infinity to positive infinity. Of course integers we have to take, not real numbers. So that is why we are negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6 and so on and so forth, right? Understood? So this is the condition, right? So it implies that only, right? Okay. Now if a divides b, it implies that a divides some b times k also, where k belongs to integers, of course. Why? Because b is equal to k1a, correct? So it implies that bk is equal to k1 into a, correct? Now k is an integer, k1 is an integer, so product is always integer. So it implies that a divides bk, correct? Yeah. Okay. Now suppose a divides b, then it implies that ma should also divide mb, right? Of course m is not equal to 0 and m belongs to integers, right? And it is obvious, if b is equal to ak or k, we can say it so that you don't get confused. So mb is equal to k times mb, right? We can say this since k is an integer, so it implies that, sorry, ma. Hence ma divides mb, correct? Correct or not? Correct? Simple. Okay. So let's see some questions on it, right? 11 divides 2 plus a and 11 divides 24 minus b. Then prove that 11 divides a plus b, right? Okay, so how can you do this problem? Well, so we know that if 11 divides x and 11 divides y, it implies that 11 divides their linear combination also, k1x plus minus k2y, right? Correct? So we can do this only, right? So we get 11 divides 2 plus a, and 11 divides 24 minus b, right? Okay. So notice that if you take the difference of these two quantities, that is 2a plus 1 minus this quantity, you will get a plus b minus 22, correct? So we get 11 times, 11 divides 2 plus a minus 24 minus b, hence 11 divides a plus b minus 22, correct? Now notice that 11 divides 22, right? So it implies that a plus b should also be divisible by 11, right? So it is equivalent to saying 11 divides a plus b, correct? Correct or not, right? Hence proved. Or if you don't want to apply this method, there is another method, right? Just say 2 plus a is equal to k1 times 11, right? And 24 minus b is equal to what? Is equal to 11 k2, right? Just subtract them, you get a plus b minus 22 is equal to 11 times k1 minus k2. Just bring this 22 over there, so 8 plus b is equal to 11 times k2 minus k1 minus k2 plus 2, right? And again this is an integer, so 11 divides a plus b again, right? Correct. Okay, so let's see some other concept, or if we have any other problem we can discuss that also, right? So in this we have to find number of positive integers. It is also expressed as z plus, right? Number of positive integers, right? Such that positive integers n such that n less than 19911 and n square plus 3n plus 2 is divisible by 6. That is 6 divides this quantity. So how can we solve this problem? Let's see it. Now we all know that this is factorizable, correct? So let's factorize it. So n square plus 3n plus 2 is equal to n plus 1 into n plus 2. Do you know how to factorize? Well, if you don't know, let me tell also. And yeah, how did I know that I have to factorize over here? Because when I read the problem, I saw a 6 over here and I saw this expression. And when I analyzed this expression, I saw that it is factorizable. So why can't I factorize it? Let's factorize. It is just an attempt. We don't know that it will solve our problem or not. It is just an attempt, right? Understood? There's a difference between analyzing a problem and completing its solution, right? So we are just analyzing right now, not completing the solution, right? Okay. So I analyze that it is factorizable, and of course how it is factorized, n square plus 3n plus 2 is equal to n square plus 2n plus n plus 2, correct? Right? So we get n times n plus 2 plus 1 times n plus 2, which n plus 1 into n plus 2, right? It is simple, right? You must have studied in your 10th grade also. Maybe you have studied in your 8th grade itself, right? I guess. Okay. So whatever the case, okay. So it implies that 6 divides n square plus 3n plus 2. It implies that 6 divides n plus 1 multiplied by n plus 2, right? Okay. Now one thing you should observe is that 6 to be divisible by 6, the number should be divisible by 2 and 3 both, correct? You know it. Okay. Now when you notice this, you see that it is the product of consecutive numbers, consecutive positive integers, right? So it implies that this is always even. Why? Because we have only even and odd pairs, right? I mean, consecutive numbers means one can be even, one can be odd, or one can be odd and other can be even. There's no other possibility, right? So it means that their product will always be an even number. Correct? Correct or not? Correct? Okay. Hence, n plus 1 into n plus 2 is always divisible by 2, right? So we have to just check for divisibility by 1, by 3, I mean, right? Okay. So notice that now I can make 3 conditions in this. Why? Because we have to check that whether it is divisible by 3 or not, right? So I can write it as n is equal to, we can make 3 conditions that if n is divisible by 3, if n is 3k plus 1, or n is equal to 3k plus 2. Why am I writing this? Because if the number is divisible by 3, then it will have 0 as the remainder. When it is not divisible by 3, it will have 1 or 2 as the remainder, right? And of course, we can write every number like this. It is obvious, right? Correct or not? Correct, right? Okay. So if it is equal to 3k, then we will have 3k plus 1 multiplied by 3k plus 2, which is not divisible by 3. If you substitute 3k plus 1, we have 3k plus 2 multiplied by 3k plus 3, and of course 3 is common this, so we get 3 times 3k plus 2 multiplied by k plus 1, correct? So it is divisible by 3, correct? And when you substitute it over here, so you get 3k plus 3 into 3k plus 4, right? And of course it is also divisible by 3, right? So this is the only condition when n is not divisible by 3, right? Correct or not correct? Okay, so what can be its condition? That n is equal to 3, 6, 9, 11, I mean 12, and so on till. So how do we find that the last digit will be what? Well, it should be divisible by 3, right? Now the sum of digits of 1, 9 and 1 is equal to 20. So if I subtract 2 from it, from that number, I will get the sum of digit as 18, which is divisible by 3. So minus 2, so 1989 will be divisible by 3, right? Correct. So how many such numbers are there? Well, you can apply the formula of AP. 1989 is equal to A plus n minus 1 into D. So you get over here 6, you can solve it. 1986 is equal to 3 times n minus 1. So you get 6, 1 carries 6, 3. So you get n is equal to what? Sorry, 2. N is equal to 6, 6, 3, right? Hence, how many numbers are there from 1 to 1991? It is 1991 number only. 1991 minus what? 663. And when you solve it, what you will get? 1991663, right? 1 and then let carry 1, 3, 1 carry. So we get over here 8 and here we get 2, right? So 1328 is the answer, correct? Okay. So this was a nice problem which you can try again, right? Repeat it. Correct? Okay. So let's see other properties, right? Let's see another property. Product of any r consecutive integers is always divisible by r factorial, right? Suppose I take 3 into 4 into 5, so it is of course divisible by 3 factorial. If I take negative 3 into negative 2 into negative 1, it is of course divisible by 3 factorial, right? If I take negative 3 times negative 2, it is divisible by 2 factorial, correct? If I take negative 5 into negative 4, it is of course divisible by 2 factorial. If I take 10 factorial into 11 factorial, it is of course divisible by 2 factorial, correct? Okay, since there are 3 numbers, there are 3 consecutive terms, so we have 3 factorial, here also 3 consecutive, so 3, here we have 2, so 2, here we have 2, again 2, here we have 2, so that is again 2. But how can we prove it? Let's see it. So we can assume the consecutive numbers as n into n plus 1 till n plus r minus 1, correct? So here we have included all the numbers till r, right? Correct or not? Correct? Okay. Now their product, it can also be written as 1 into 2 into 3 till n minus 1 divided by 1 into 2 till n minus 1 into this quantity n into n plus 1 till n plus r minus 1, correct? Now what is this expression? It is equal to n plus r minus 1 factorial divided by n minus 1 factorial, correct? Okay. So what can be done next? Well, let's divide both sides, I mean denominator and numerator, by r factorial, right? So you can write it like r factorial multiplied by n plus r minus 1 factorial divided by n minus 1 factorial into r factorial. Okay, so we got this, but what's next? Well, it's very easy now. R factorial multiplied by n plus r minus 1 factorial, we can write it like this: n minus 1 plus r minus r factorial into r factorial, correct? Or you can write r factorial into n plus r minus 1 factorial divided by n plus r minus 1 factorial minus r into r factorial, right? Like this. And it is equal to n plus r minus 1 cr. Correct or not? It is equal to n plus r minus 1 factorial divided by n plus r minus 1 minus r into r factorial, right? Like this is what I have written. So it is equal to r factorial into n plus r minus 1 cr. Correct. Hence it is always an integral value, right? So it implies that this product is always divided by r factorial, right? Now suppose if you have negative numbers, then in that case, well, you can just take negative sign common, you raise to some power. If the power is even, then it will be positive only. If it is negative, then leave that negative sign and treat all numbers as positive number and then solve it, right? Simple, right? Okay, you will get this result only. Okay, correct. Okay, so let's see some other properties and problems, right? Okay. So we can do a problem also. Prove n to the power 5 minus 4 n cube plus 5n, I mean plus 5n and this plus 4n is divisible by 120, right? Of course, n is greater than, we are given n is greater than equal to 1, right? Correct or not? Correct. Okay. So now let's see it. Okay. Well, we can take n common. So of course, it seems so difficult when we first is divisible by 120, right? So of course, when we see this problem, it feels so difficult. But if you apply that property, it will become super easy. Let's see. N to the power 4 minus 5 n square plus 4. So it becomes n to the power 4. You can factorize this. It will become n to the power 4. So it will become n to the power 4 minus n square minus 4n square plus 4. So we get n to the power, sorry, it will be n only. Why I wrote to the power 4, I don't know. It is n square minus 1 minus 4 into n square minus 1. So we get n times n square minus 4 into n square minus 1, and a square minus b square is equal to a plus b into a minus b. So we get n into n minus 2, n plus 2 into n minus n plus 1 into n minus 1, right? So we get n minus 2 into n minus 1 into n plus 1 into n plus 2, and of course by the property that r factorial divides n into n minus r, sorry, n plus 1 till n plus r minus 1, right? Their product. So it implies that 120, that is how many terms are there? 1, 2, 3, 4, 5. It implies that 5 factorial divides n minus 2 into n minus 1 into n plus, I mean into n plus 1 into n plus 2, correct? So what is 5 factorial? It is 120, right? So 120 divides this expression. So 120 divides this expression, right? Hence proved. Simple, right? Now let's discuss another property, that is x plus y divides, always divides x to the power 2n plus 1 plus y to the power 2n plus 1, right? For all n belonging to integers, right? Positive integers, right? And of course you can include 0 also in this, so union 0 you can say, right? Or you can say it belongs to whole number basically, right? Simple. And x minus y is divisible by, I mean x minus y divides x to the power n minus y to the power n for all n belonging to whole number. Correct? Correct or not? Correct? Simple? Right. Well, if you substitute n is equal to 1, you get x cube plus y cube. So of course it is equal to x plus y multiplied by x square minus xy plus y square. So it is of course divisible by x plus y. Here if you substitute 2, you get x square minus y square, which is equal to x minus y multiplied by x plus y. And if you substitute 3, you get x cube minus y cube, which is equal to x minus y multiplied by x square plus xy plus y square, right? So in that case, it is always divisible by x minus y. And of course, I have made a video on this topic, which you can see, right? Okay, so let's see it now. So that is the property which you should remember, right? So let's see a question on it. Suppose I give you question, prove that 10 to the power 13 plus 12 to the power, I mean 13 to the power, let's raise it to the power of 27, 272, 2712, 567, 567, right? 271, 271, 2567, right? Is divisible by 13, by 23. So how will you do it? Well, you saw odd power in the exponent and here also odd power, and they both are equal. So it means, so we'll apply this property, x plus y divides this quantity, hence x plus y, that is 10 plus 13, that is 26, divide this number, and it is true, right? From this identity, from this property, we easily derived it. Else just see the power, it is so big, it is like very difficult to think even, right? Okay, suppose I give a power, I mean a question, 1 to the power 1997, 2 to the power 1997, and so on till 199, 6 to the power 1997 is divisible by 1997. You have to prove it. So how can you prove it? Well, at first you think that how will be done, but when you take this term and the last term, you will see something interesting. 1 to the power 1997 plus 1996 to the power 1997, okay, plus 2 to the power 1997 plus 1995 raised to the power 1997, right? And so on. And of course, it will always end up in pair. Why? Because we have even number of terms, right? Okay. Now it will divisible 1 plus 1996, right? Correct? Correct or not? Correct, right? This property. So it is divisible by 1997. This also divisible by 1997. And whatever numbers you get, it will be always divisible by 1997. Hence, this whole expression is divisible by 1997. Correct? Correct or not? Correct. Yeah. Now suppose I give you a question, 10 to the power 25 minus 8 to the power 25 plus 6 to the power 25 plus 4 to the power minus 4 to the power minus 4 to the power um, minus 4 to the power, what you can do is over here is that 20, or you can write it over here as 3, here you can write it as 5, correct? 5, and over here you can write it like 1, right? 1 to the power 25, right? Let's take this example, or I can change this problem a bit. It can be written as 11, it can be written as 6, it can be written as 7, it can be written as 2, right? Now it is better, right? So you have to prove that this is divisible by 5 always. How can you prove it? Well, again, this is divisible by 5, right? 11 minus 6 is 5, so it is divisible by 5 always. 7 minus 2 is always divisible by 5, so it is also divisible by 5. If both are divisible by 5, then their sum will also be divisible by 5, so it will be also divisible by 5, right? Hence, this is the method, right, which you do. So with this, we come to an end of the first lecture of number 3. I hope so that you enjoyed this video. If you did enjoy this video, then please do like, share, subscribe my channel, and please support this video. Bye bye, take care, and all the best.